We are given that the particle moves along this curve given by this equation, that is y equals under the root of 24 plus x cube. And as the particle reaches the point 1 comma 5, its y coordinate is changing at the rate of 5 centimeter per second. So mathematically, I have written this as dy by dt equals 5 centimeter per second. And we wanted to find the rate at which the x coordinate changes at that instant. So mathematically, it is dx over dt, and that's what we have to find. So let's see how to determine the dx by dt, which represents the rate of change of x coordinate at that instant. So to determine the dx over dt, we have to differentiate both sides of this equation with respect to time. Before we start to do the differentiation, I'm going to rewrite this equation in terms of exponent form. That is, this is under the radical form. This can be written as 24 plus x power 3 raised to the power of 1 by 2. So that we can do the differentiation using the power rule. Now let's differentiate both sides with respect to time. So the derivative of y with respect to time is dy over dt. And here, to find the derivative of the right side expression, basically we have to apply the chain rule. And when we apply the chain rule, we have to consider the outside function as well as the inside part or the inside function. And we can see from here that the outside function is a square root function. So first, let me apply the power rule to differentiate the power function or the square root function. So I put this 1 by 2 in front, and then I put this as 24 plus x cube raised to the power of 1 by 2 minus 1. So this is we get when we differentiate 24 plus x cube raised to the power of 1 by 2. So we have done this using the power rule, that is the derivative of x raised to the power n, and this equals n times x power n minus 1. Since n equal to 1 by 2 here, I put the 1 by 2 in front and then reduce the power by 1 by 2 minus 1. So let's continue. We are done with the derivative of the outside function. Now we have to find the derivative of the inside part. So this time I'm going to put this as a d by dt of 24 plus x cube. You'll find its derivative in the next step. So let's simplify this. So we have dy over dt, which is the rate of change of y with respect to time, and this equals 1 by 2. We can rewrite this. This is 1 by 2 minus 1 is negative 1 by 2. So I'm going to put 24 plus x cube raised to the power of negative 1 by 2. In fact, we can rewrite this expression in terms of positive powers of the number, because we know that x raised to the power of negative 1, we can write, or let's say it is x raised to the power of negative 2, we can rewrite this as x raised to the power of 1, 1 over x raised to the power of positive 2. So if that is the case, I'm going to rewrite this expression as, I'll just rewrite it and put it over there. This is 1 by 2 times of 24 plus x cube raised to the power of positive 1 by 2. In fact, we can reduce this to, or we can rewrite this in radical form now, that is as a square root form. So this becomes 1 by 2 times of under the root of 24 plus x cube. So basically we have converted this expression as like this. So let me put it over there. So now I have put that expression over there, and then we have to multiply with the derivative of the 24 plus x cube. Let's see this. So we have to apply the chain rule over here. The derivative of 24 is 0, plus the derivative of x cube is, when we apply the power rule, we get 3x squared, because we have to put the power in front, that is the 3 in front, and reduce the power, that is 3 minus 1, which is 2. And we also have to apply the chain rule to find the derivative of x with respect to time, and which is nothing but dx over dt. So it's basically the derivative of this is 3x squared times dx by dt, because we can just remove this x, and I'm going to put that expression over here. So this is   plus,  3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus  3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squared times dx by dt. So this is   plus, 3 x squared times dx by dt, plus 3 x squa Okay, I have put that expression with this term. So this is basically the expression for dy over dt. Now we can utilize this to determine the rate of change of x. That is, we have to solve only for dx over dt. So let's solve this. Or else we can also plug in the values which we know, and after plugging the values we can determine the dx over dt. So let me do that. We know that dy over dt is 5 centimeter per second. I'm going to replace it over here. That is dy over dt. I just put only the numbers which is equal to 5, and this divided by 1 over 2 times of under the root of 24 plus the point is x comma y is 1 comma 5, so we have to plug in x equal to 1 here. So it becomes 1 cube times 3 times of 1 squared times dx over dt. We can now solve for dx by dt from this. Let's simplify this. So we have 5 here, and this equals 1 over 2 times of 24 plus 1 cube is 1. So it is 24 plus 1 is 25. And the square root of 25 is 5. So I put 2 times of 5 multiplied by 3 times of dx over dt. So this gives 5 equals 2 times of 5 is 10. So we have 3 in the numerator. So we can rewrite this as 3 tenths times dx over dt. Now to solve for dx over dt, we have to multiply by 10 and divide by 3, or otherwise we multiply by 3 tenths on both sides. So when we do that, we get 5 times of 3 tenths, and this equals, if we multiply 3 tenths, I'm sorry, we have to multiply with 10 thirds. It's not 3 tenths. We multiply with 10 thirds. So 10 thirds. And when we multiply 3 tenths with 10 thirds, this will get cancelled. So basically, on the right side, we will have only dx over dt. And so dx over dt, this equals 5 times 10 is 50. And we have the denominator 3. So it is 50 over 3. This is in fraction. When we convert this to decimal approximately, it is 16.67, and we have to put the unit as centimeter per second. So here also you can put the unit as centimeter per second. So this is the rate of change of x with respect to time. That is, the x coordinate is changing at the rate of 50 over 3 centimeter per second, or 16.67 centimeter per second.